Welcome to Crypto 4.0 Artificial Intelligence channel. Today I will present the case 11, Injection Price Prediction. So again, our supervised machine learning regression basically collects a set of data, splits this data set in training and test data. Then we choose one regression model, and as I explained in the first video, when I explained the concept of regression models, supervised machine learning regression, this regression model will be chosen based on smaller root square mean error. That's basically the error that's considering the predicted values and the real values. Then I will verify this error and compare different models. The one that have a smaller error I will choose. Then a new data will come out. A new data in our case I will use as a first data to training and test the model. The prediction, the historical data until November 2024, and then of course the new data will be the prediction for 2025, and then of course I will validate my model. So let's take a look on how I can get the data. So as I've made previously, I go to this website here, CoinMarketCap. If you have another source of data, you can also split. I use this one because it's very simple. Here I need to choose the all periods, so that shows the price of the injective along the time from the beginning. And then in this icon here, I will get my data, that's the historical data, and then I will prepare the data for the prediction. So let's doing that. So now I am on website. I download historical data. This is injective historical data. Need to wait for the download. Yep, the file is opening here. I click twice, so I get the first one here. Yeah, injective data. So the file is open. That's here we have inject. I will save this file on my computer. Okay, and now what I'm going to do, I will prepare my data. So I will save the file with another name, injective price, and then I will take it out some information that I will not use. This is the time, market cap. I will use market cap. I will not use the name, and the first I will delete this one, and I will use this price here. This is the price that was closed during this specific day. And then I need to check now the template to check if everything is, I have all the information. My data set, I do not have the information from this month, so I will not use information from December. I just use the information from November. So my prediction will consider December and on. So I will delete in here. And that's the database that I will import and training. This is the database here. The first one is the database from the beginning to November 2024. As this database here is the one that I will train in my model. But I will need to do the prediction as well. So I will save. And then I save another name here as 25. Okay, so now what I'm going to do, I use the last price for 25. I will delete all this information based on this last price. I will calculate the next price. So, but I consider here, as I did before, that I'm using increasing this value in market cap from 10% of the last value. So, and then I have a range of market cap and volume of transactions, and based on this market cap and volume of transactions, I will be able to have a sensitive analysis concerning the possible price, concerning the possible market cap. So now it's very fast. Now I just need to update in here for 2%, 20%, it will be 30%, 4%, 40%, and so on. So I preparing my data for the new data that I call on my model. So first I will train the data, and then I will prepare the data set. I will use this data for prediction. So basically, here's 80%. Okay, here's 9%. And then of course, depends upon the market cap value, I will not use all this value, because I will not expect, for example, as I made in the previous model, that Injective gets a rank in terms of market cap higher than let's say Bitcoin, for example. So it's too extreme. So if I based on market cap, I will limit my prediction, and then I have a sensitivity case, and I will can see, depends on the market cap variation, what is the range that I can achieve. So let's stop here in 400, and let's make the same calculation for market cap. Okay. So here, for example, is something already higher or equal to Bitcoin, what I not expect. So it's making no sense to make predictions of the price if the market cap is higher than Bitcoin, because I don't believe that we get in this value. So I will format this value here so that make easier for my visualization. And I will copy and paste this first value here that I work on it, and I will delete this one. Okay, I have almost finished. So I will get the opportunity to work in this file and save this file result. Result is where I will put in here the result of the model. Okay, so then I need to come back here now in my file and open this file here, 25. This is the new data on my model. Then I will delete here. Oh, they ask to convert. Okay, I will delete this column here to not, because this column is not part of it's not similar to the previous template. So whenever I use a database in an Excel format for the training data, the new data need to have the same format. Now I have in the same format, so I can see here is around 3, the market cap is around 3 billions, and then I have 4 billions, 6 billions, and here I have already 10 billions. And here is already in the range of mid cap, so that's possible. We see that that's possible, but in these values here is too high already for the prediction, but we'll check what's the price that will predict, that the model will predict for each market cap and volume of transaction. So my next step is to open my MATLAB software. So I will import my historical data, and then when this was the preview model that you can see here, but when I say that I don't save it, they will delete this information and the new data set will open. I need to go to the new data set and open the injective file here. Okay, this is the database. Then they will import the data. As I mentioned before, the next step, that's the MATLAB software now. They need to know which are the response variable, that's independent variable, and which are the dependent variables. Our dependent variables are always volume and market cap, and the independent variable that they call response are is the price. So they are open the file, and then I need to confirm that this is my data. Then I import it. I confirm it here. When I confirm it here, the data will be imported, and a new window will open up. The same step that we had before on the previous model. And now, as I mentioned here, I need to select the response. So my response is price, and volume and market cap are the predictors or dependent variables. And here I need to set up the test and training data. So as usual, I put 30% of my test data. And then I start the section. So now what you're going to see is that this template will be updated, and this previous information for the previous model here will disappear, as well as this graph. And a new graph will shows up. I will have to choose the variable that I will use, because it's a two-dimensional graph. Two-dimensional meaning there are two variables only represented in here, so I need to choose which are the two variables represent this graph. And that is the next step. So now we can see that the graphic is open, as I mentioned. So here I will choose volume, and then that shows the volume of transaction and the price. And then now the next step is to choose which are the best model to make which are the best supervised machine learning regression model to perform this price prediction based on regression. So I really want to train all the models that I have available in the MATLAB software, and I will check the mean square error that the software will produce. So here I already have one model. This is 2.1. Let's say 2.1 is linear regression. So far the linear regression stepwise are the two models with the smaller root mean square error. And then, as I mentioned before, you choose the model that have a lower mean square error. So if I compare, for example, the linear regression with these tree model, the tree model have a higher value when I compare to stepwise linear regression and linear regression. And that means that I will use linear regression as a best model or stepwise. That's my decision. Stepwise is a better model because, as I mentioned before in the first video, the stepwise regression, they eliminate the variables that have no significant relation with the predictors. So they eliminate the dependent variables that have no significant relation with independent variables. So that's very interesting model. So since that now is finished, so I can go scroll down. I got linear regression 2.96 here, and yep, this is the best. And then I need to check which are the best results. So in the end, the model was updated. Actually now I have the best result indicated here is the ensemble method. Let's have the root mean square error as 2.67. So I use ensemble method. So I choose, when I click in here, what's happened, the model is updated for 2.16. And then I need to get my new data, my new graph, and then I can see the variables here, the true variables that was and the predicted one. So, and then they calculate the error for the predictions. Okay, so, and then the model are based on the error that we have. I choose the model based on the error. And now the final step, I will export this model to another templates that I have in the MATLAB. So here's one window. I have the second window here. This is the second window where my model is exported here. So I can see here my model, and then what I'm going to do is copy this model here. Let me copy this model, this equation here. This equation represents this stepwise model that was predicted in the app. And now all I need to do is to import my data from 2025, the inject 2025 file. So this is the one that I work in Excel based on possible market caps. So I need to come here in my file, injective prediction, and then the database will open up here to confirm. So see that here there is no price, and I confirm to import. I will close this window, and here is the price. So what I'm going to do now is to copy this name to be sure that I do not type wrong name here, and replace this T by this name of this file. And the model will automatically predict the price of injective based on this market cap. So I just need to put my icon here and click enter. And here we are, the price of the prediction. We can see that the price is very similar. Around 35, 36, there's no variation. So what I'm going to do, I will test another model. So I will come back, because I do not expect this time stay constant independently of the software results. So I will check some other model that have similar smaller error close to this 2.76. So for example here, let's see, this is almost 2.7. So I will get neural network. So neural network. So let's take this neural network for example, and then I will make the prediction based on this neural network that have a similar error when compared to this assemble method. So this is very interesting case, because I need to also to assess the results. So mathematically, the ensemble method was the one that produced smaller error compared the models. However, when I performed the predictions made no sense for me, because I did not see variation in price independent of the market cap. That's why I will not use the ensemble method. I choose another method. So I choose neural network because usually the neural network is the one that has very good result on regression prediction. Then I need to do the same step. You saw that I click on export data, and here comes with model 1. So again, I confirm, and then I come back to the other window. Now I have the model 1 here. So we can see I have a model and model 1. This is the equation here that I have. This is the equation model 1 that I have here below. So I need to do the same exercise, but here we can see model 1, model 1, and then I will paste it here below. And then again, what I'm going to do is to copy and paste the name of the file that I want, that I have a new data, new market cap to predict the price. Click enter, and then the software will calculate the price. So now I have the price, different pricings here, so that makes sense for me. but this is multiplier for 10 plus 4, so for 10,000. And then if I want to make simple my case, I can just come in here and check which are the real value. So it now makes sense. I see that's based on neural network, the price is starting to increase along the time. So for 30,000 for, and then 10x here, you can see this is the price to the price, current price is not in this level, but here in this area it started to come around 34. So what I need to do now is to copy these values here and put on my file filter and make the assessment there. So I have a good result. So I will come out here this file and paste. Yeah, this is the file, paste the price in here. Okay, so yeah, that is fine. So what I'm going to do, I just put yeah, now this makes sense, make easier my calculation. Okay, and now what I'm going to do, just to check the current price for Injective, okay, it's 28.16. And now I come back here, so just make some calculation to see how much X I have. 28.16. Okay, now I can do this value divided for 28.16. Then I have the idea precisely how much X I have. So let me, okay, so here I just put this cell constant because I want to do also, I want to know also the other values, and then I paste below. Okay, and now I also reduce this. Okay, I will copy again here, and I can make this goes, and then I just put X here. So we have that 1.2x, 1.5x, and so on. So here we are. I will put percentage, and I will put X here. So I understand that's how this really means. So here I have my final prediction. So let's just check the market cap for Injective. So here's the market cap. I have already 2 billions 75. So is already in the bottom of medium cap classification. So that means they need to have some let's say they have 2 million, so in market cap 2 million, so they are already mid cap. So we expect that the price now goes to 34, 42, and then of course for a mid cap to get 10x they will have to get this value over then, let's say 10 billions. So that is basically what is the classification shows us. So when, yeah, so they need to goes from medium cap that they are now, they are a little bit higher than 2 billions. Actually they are really, as we mentioned here, so let's shows again. So the market cap here is higher than 2 billions, so they are medium cap as a classification already. So but they need to go higher, so need to get here, for example, in this region, when you get this point, the view are higher than they are our larger cap. So in this point here, this coin, this Injective, will be a larger market cap, but you get only 4.2x. So they need to get a higher, let's say to 30 billions to get the 10x, or 4 billions to get 10x. Yeah, that's something that we expect. Is we then of course if they higher they increase their market cap, the higher we expect this price. Yeah, but to be realistic, something 10 is something that's already challenging in terms of market cap. So let's just take a look on very important assessment. If you should take a look on the rank, the current rank of the cryptos. So let's see what does it mean in terms of rank. So if you look on nowadays the market cap, you can see here the XRP, for example, they have 136 billions. So 100 billions. So here, basically, to get, if they get to 24 billions, so something that's close to Avalanche here, or Cardano, 40,000 billion, they are in between the 10x coin price. So these values here is 10, 30 here, for example, is close to their, if they get this point, this market cap here, that's 27 billions, they are in the rank of the 10, and then that we have here is actually is 24, something higher than 24 that we have today. So higher than 24, yeah. So basically they need to get something. This is the line. So if they get in the 10th of the rank, they are between the 10th highest market cap, they will get 10x from the current price that we have now. So basically that's what I do. If they as higher as they are getting the position, they will getting they will bet the appreciation will be higher. So just to have an idea, so what this appreciation is about. So let's see, we are here. So XRP, if they get close to XRP, if they get this position higher than Solana, that's quite challenging. Let's put 100 here, lower than Solana and XRP. That's yeah, it's still challenge, but well, let's say possible 100 billion. What does it mean in appreciation? So 100 billions will be something here. So they will get 44x. So if they get this best position, so yeah, that's quite challenge. But yeah, more to be more realistic, that would be something that would be the top. Let's say that would this injective would achieve. But I think that's 10x, 20x is more realistic for this coin. Okay, so that was the presentation. That was the presentation that we present the injective price prediction. So thanks for attention. We'll see you in the next video.